let's see if everybody can hear this. Looks like we're going. So right now, I'm going to walk you guys through Ignitors a little bit. So up until now, we have pretty much covered the first few steps of the sequence. So the way I've taught this class in the past is you guys will walk through the first steps, and then we'll kind of teach them as we come to them. So we're going to do the same thing this way. So the first few steps up to this point, thermostat calls for heat between R and W, 24 volts from R to W. So if you're reading from R to W on a call, you have 0 volts between them. W goes to the furnace, and the furnace usually has some sort of ignition control module that controls the flow of electricity to the different components. So different than most things, this kind of has its own module. Once it gets a call for heat, the module usually takes care of it itself. So it's a little bit different than what we're used to. So what I'm going to do now is show you all a couple of things. So let's see if I can do this. All right, so hopefully you can see when I change the screen. And so I've posted a new lab assignment. So if you go to Blackboard into lab assignments, there's a simulation for, apparently I haven't posted it yet, but I will post it. So there'll be a simulation for igniter, faulty igniter. So I'm going to kind of walk you through that a little bit and then let you go and do that again. So it's just kind of a practice training. I want to use this as a reminder to say, you know, you all really, most of you are doing pretty well, but just make sure that you're getting on and doing all this stuff and keeping up, because the class is going to travel pretty quick. And since this is the only kind of instruction that we have is online, you've got to be doing your part. So if you can keep up, should be in good shape. I'm going to start assignment now, though. So this will be posted, and this will be worth points. So once we get everything to load. All right. So close that. Go to the furnace. Go to the thermostat first. All right, so it should kick on. We'll go to the furnace now. Pop the door off. Take my door switch. Remember, if you don't do that, it will not work. Take your switch, and then I can zoom in and watch. So the first thing comes on is my induced draft blower. That proves this pressure switch, so I can test that with 24 volts. And then I'm looking for my igniter, which is right here on the right. So you'll notice it has 2 wires to it. This particular igniter, this is a hot surface igniter. And that should glow pretty quickly, but it's not. So at this point, then you're going to go to your procedure guide. And you're going to say, check thermostat, we did that. Remove the furnace cover, we did that. Tape the switch, we did that. Is 120 volts measured? Yes, we have power, it's running. Is 24 volts measured on R and C? Yes, we're calling. Is 24 volts measured at terminals W and C? So at this point, it should be the case. So we should be good there. Is inducer blowing? Yes. Is 0 volts measured across the pressure switch? So that we don't know. So at this point, it could be a couple of different things. It could be something with the pressure switch, or it could be something with the igniter. So if the igniter doesn't come on, your first step is to go back and make sure that your pressure switch actually works. I wish I could find a way to turn the sound off on this thing. But anyway, so I'm going to put this away and get my tools out, get my meter, turn it to volts, grab my leads, and check across this pressure switch. So what should I get when I do this if it's working? I'll give you a second to kind of think about that. If the switch is closed, it should be what? I got 0 volts. 0 volts says the switch is closed, so that tells me that it is closed, it is working. I don't know if I can reference to common on this or not. Let's see. Yeah, I can. Okay, so if I reference to common, I can check both sides of that switch. 24 volts and 24 volts. So switch is closed, switch is passing power. I can turn this off at this point and put that away. Let's see, let me pull it back out real quick. See if I can do something else. All right, let's check this. So here's your igniter. You can check this here, that's good. All right, so remove the tape and then tape it back again. Over to see if that makes a difference. All right, there I got 120 volts. So it won't call all the time. If it doesn't call after a while, it'll eventually lock itself out. So you'll notice it calls for a second and then it doesn't get anything. It doesn't actually light. It thinks it should be lit at this point, but it's not. So this is going to do this until it finally trips an alarm, and it's going to say that you have some sort of ignition failure or something like that. So at this point, don't know if I can own that switch, but let's see. So what I would do next, or not own the switch, own that igniter. Normally what I would do, but it's not going to let me do it, is on that type of igniter, if I can move in here just a little bit, see, you'll notice it's right here. So that igniter sits inside of the first burner. So if you kind of back out, you'll notice here's your gas coming in on the left. It goes into the gas valve. Gas valve passes gas from right to left to the end of the manifold. So you'll notice a couple of things going on in here. So if I zoom in, you can see the igniter. So the igniter's on the first one because you want to ignite the first gas that it gets. And then on the other end, we haven't gotten here yet, but on the other end, you'll see a flame sensor right here, and it will be on the other end of the switch. Usually it's actually looks a little different than this one. It will actually be up in the flame. So this must be back in the furnace or something. But it'll be in the flame to where it's actually sensing the last one. So if it doesn't get all the way across, then it won't make that switch. It'll tell it that it's not sensing a flame. So igniter is the first thing. So we know that it's a faulty igniter, so I'm going to go ahead and replace that. Do I wish to proceed? Yes, I do. Yay for that. So at this point, it's been replaced at 4 stars. And I'm going to run the furnace again, see what that does, and see what it looks like when it's working. I might have to go back to the thermostat. I don't know. Oh, wait, I probably have to turn the power switch out. Once I replaced the part, I had to kill the power. It killed the power for me. Whoa, furnace. Well, we missed it. Let's do it again. All right, let's back out and do that again. All right, system's been isolated. I'll tape the switch. That should have killed it, but for some reason it didn't. All right, so this happens pretty quick. Let's do this one more time. This is a lot quicker than reality, so it's happening really, really fast. There it goes. So you see it glow. Next thing that comes on is your gas, and then it ignites, comes all the way across, and burns. All right, so at this point, the only thing left to do is close up, make sure we removed our tape, which we did. Whoa. Let's go to the thermostat. Let's go back to the furnace, put the door on, turn the power back on, go to our broom, hit that, go to thermostat, turn to heat. I would think it would. No. Blower kicks on. If you go inside, walk around, go to the stat. You can look around in the room. Should be able to see that you have heat blowing into the room now. So now we're back to the furnace. Okay, so I guess it's saying we're done. All right, so at this point, we would just want to exit out, return to course, and get our points. All right, so that's that. Something else I want to show you. So now that we know kind of how it should react, I want to show you a couple things with types of igniters. So let's go back. So this is unit 31 in your textbook. And in my opinion, the chapter kind of goes backwards, but this is kind of the end of the PowerPoint, end of the chapter. So the main purpose, you introduce air, then you introduce heat, then you introduce fuel. So the fuel is the last thing in, first thing out. So different types of igniters, ignition sources. It's just some sort of heat source or flame source that ignites the gas. So it could be a hot surface igniter, it could be a standing pilot, it could be a spark. There can be different types. So the oldest type is a pilot, to where it actually uses a little stream of gas to keep a flame burning. So you may have seen these on like an old stove, or like an old heating stove, or even on some of these ventless gas heaters that people have in their houses on the wall heaters. It's just a little standing flame that burns. So that actually takes gas from the gas line. It goes around the gas valve, so it kind of gets its own source. Even if the gas valve isn't open, it gets a little small stream of gas. And then whenever it does send the gas through the burners, it's there to ignite it. So that's kind of an old tried and true method, but you still see a lot of them out there today. I don't know if there's much new stuff that comes with the standing pilot, but there is a lot of older. So I'm not going to spend a ton of time on that, but some pilots are standing, which means they're always burning. And then there's others called power pilots, to where the pilot is actually ignited when the furnace gets ready to call for ignition. So it has a spark that actually ignites the pilot, and then the pilot ignites the burners. So it's just sort of a multiple ignition source. I don't really know the advantage for that versus just a standard pilot or a spark ignition. So it's like, to me, it seems like there's more things that could go wrong there, but I'm sure there's a reason. Right. So one thing that you have to do with a pilot or any sort of gas is you have to make sure that you're proving that it's actually burning, because if not, you're going to just sit there and dump gas into the space. And this stands true even for the pilot. So we haven't really talked about a flame sensor yet on a furnace, but kind of leads us into that for the next discussion. Flame proving, the way that most pilots do it is they use a thermocouple or a thermopile, and I'll share some stuff that shares a little bit about that later. But basically, a pilot heats a part of this kind of like a stick or a metal stem that sends a signal once it's ignited, once it's burning, that that sends a signal back to the furnace to say that it's heated up. There could be some others as well, but that's kind of your most common, is it uses a thermocouple. So if I can go to a different screen here and pull up, I don't know if I'm gonna be able to do that right now. Well, anyway, I've shared a file on Blackboard that's called Igniter types, and it's in this module. So once that opens up, you should be able to see all that. Intermittent pilot ignition. Intermittent means that it ignites the pilot or the main burner. So this isn't a standing pilot. Standing meaning it's always on. This is an intermittent, which means it only comes on demand. So it's a spark type igniter, kind of similar to what you'd have on a gas grill. You hit that and you kind of hear that, and then it lights. So that's one of the telltale signs that it's a spark, is that you'll hear that little click, 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 and then that causes it to ignite. Kind of works like a spark plug actually would. So let's see. Direct spark, no pilot is used. So a pilot is what you're using if you're using a flame to light it. But if not, you're going to use some sort of direct spark ignition. So you have hot surface ignition. That's one way to do it. Uses some sort of carbide placed in the gas stream. So this is just a hot surface. There's no flame. There's no spark. There's nothing that's actually burning. It's just a hot surface that is hot enough that it glows red enough that it allows it to ignite. All right, we talked earlier about the flame actually sending a signal. That term is actually called rectification, which means that it uses some sort of sensor. That rod acts as a sensor. So when that flame goes across it, it actually completes a circuit that converts to power, sends it back on that wire from that thermocouple, and sends a signal to the furnace to say, we have a flame. Kind of confusing to understand, but I've got to stop this, guys. All right, so sorry about that. I had to answer a phone call, but let's pull this back up. All right, so that's your main types. You have hot surface igniters, you have some sort of pilot, and then you have spark. That's probably your common three, and then within those you may have different variations of those, but that's your main three types. So if you want to get on Blackboard and just kind of check out that that paper that I shared with you, you can see the different types, see some pictures. I'll probably be sharing some videos as well on the different types, but that should pretty much cover the nuts and bolts of it, I guess. So I'm going to kind of stop with the lecture part, and then I'll upload some other stuff so you can check that out. Make sure that you're doing your assignments. You're doing chapter 30, 31, 32 at least, and then make sure that you're doing those lab assignments through MindTap, because as of right now, that's the only way that we can really prove your lab grade. So if you can try to get on there and do that, that'll really make things a whole lot easier for everybody. I know this isn't ideal, but hopefully we can get through this. So if everybody can be patient and try to work ahead, try to stay on task. You won't get too far behind, and this shouldn't be too bad. If you got any questions, email, call me, whatever, and I will talk to you guys soon.